Hey guys, welcome to Chapter 4 Notes on Transformations. Today we are getting started with Section 4.1 and we're looking specifically at translations. Our learning targets for today are to be able to write a translation rule for a figure and translate that geometric figure in the coordinate plane, and to be able to perform a composite of translations. Before we jump in, let's take a look at a few definitions. A transformation, first of all, is a function that moves or changes an existing figure known as the preimage to produce a different figure known as the image. There are four main types of transformations that we'll be looking at. The first is a translation, commonly known as a slide. This pushes all of the points left, right, up, or down, or a combination of those in the coordinate plane. A reflection, known as a flip, takes a geometric figure and flips it, changes the orientation over what's known as the reflection line. A rotation, commonly known as a turn, takes a geometric figure and rotates it around a center or a point of rotation a certain amount of degrees. And then finally a dilation, which can be a stretch or a shrink depending on if we're enlarging it or reducing it. Takes the figure, the geometric figure, and changes its size. Today, though, we're specifically looking at a translation. As we mentioned, it is a slide, and that slides every point in the preimage figure, that's the beginning figure, the same direction and the same distance to produce the image figure. Over here on the right, we've got an example. We are taking each point in the preimage triangle, x, y, z, and translating it the same distance and direction to get the image triangle x prime, y prime, z prime. So you see that little apostrophe, that's the thing that we call the prime, and it represents the image or the transformed figure. All right, we want to describe the movement. So the best way to do this is just pick a point. Let's take the point y and describe the movement going from y to y prime. You would have to move over 1, 2, 3, 4 units to the right and up 1, 2 units up. So we say that's 4 units right and 2 units up. That's the description of the movement. Now each one of our points from the preimage are going to move that same amount. If we take x, go 1, 2, 3, 4 to the right, and up 1, 2 units, you'll notice that we're at x prime, and the same is true from z to z prime. That amount of movement is known as the vector or the translation vector. And a vector is simply a quantity that has both a direction and a magnitude or a size. The notation for vector looks similar to the notation for array. But a vector, and you can see vector PQ over here on the right hand side, has a beginning point, an initial point, and an ending point known as the terminal point. So it begins and ends, and that's a little bit different than array. So notice over here on the right, here is vector PQ, and it begins at P and it ends at Q, the terminal point. Well, to write a vector in component form, this component form here has these sharp brackets with two numbers listed inside those sharp brackets, separated by parentheses. This is the notation that gives the direction of the vector, where A is the horizontal movement and B is the vertical movement. So again, going back over here to our example, from the initial point to the terminal point, we move 5 units to the right and 3 units up. So our component form for this vector is +5, +3 inside those sharp brackets. Now the translation rule is a rule that expresses a translation along that vector AB. And the rule tells us how to change the ordered pairs. Here is a translation rule that says take each original ordered pair xy and add a to the x and y to the b. This is going to move it along that translation vector with the component form of a, b. Let's take a look at example 2. Translating along the vector 6, -2 can be done using the rule xy goes to x plus 6 and y minus 2. The description of this translation vector would be moving to the right 6 units and down 2 units. That is why we are adding 6 to the x and subtracting 2 from the y. So it says describe how this translation vector changes or slides a preimage. We would say right 6 units and down 2 units. All right, moving on now. Example 3 on the back side, it says to describe the vector and write its component form, then give the translation rule. So here's our vector hg, and you can see here h is our initial point, it's our starting point, and our terminal point is up here at g. So g is where it ends. So this is the vector capital H, capital G, and it gets one line over the top with just a top arrow, kind of like a harpoon. It's not a traditional arrow there. So this is vector hg. In component form, I now have to look at its movement. So it looks like going from h to g, I'm moving to the left 1, 2, 3, and I'm moving up 1, 2, 3, 4, 5. So that's -3 because I'm going left, and +5 because I'm going up. So in component form, I would write that as -3, 5. And it's going to be inside those sharp brackets there. Don't put the soft parentheses because that would mean an ordered pair. Next, we want to write the rule, give the translation rule for this vector. So the translation rule tells us that all of our original ordered pairs are going to be changed by subtracting 3 from the x's and adding 5 to the y's. In words, that would be left 3 and up 5. Next, we want to describe or find the magnitude, which remember is size or the length of that vector. Well, to find the length of this vector, it is simply the hypotenuse of this little right triangle. In order to find the hypotenuse, when we know the two legs, we're going to use Pythagorean theorem. So good old Pythagorean comes back to us in this chapter again. So we're going to say -3 squared plus 5 squared is equal to c squared, where c is the length of the hypotenuse of this right triangle, and that's the magnitude of that vector. So that gives us 9 plus 25, which is equal to 34, equals c squared. Next, we got to take the square root of that. So the square root of 34, which is approximately 5.8, is the magnitude of that vector. All right, moving down to example 4, we want to find the image coordinates of our quadrilateral ABCD under the translation -5, 3. So it looks like we're going to slide it left 5 and up 3. Fill in the chart below to help organize your thoughts. So these little T-charts here are a nice way to organize our thoughts, where we have our pre-image coordinates on the left, the rule in the middle, and the resulting image coordinates on the right. So let's fill this in. You'll notice that we got ABC. Our D coordinate here should be the coordinate 1 over and -3. Next, we're going to run it through this rule where we're subtracting 5 from the x and adding 3 to the y. So you'll see that we got 1 minus 5 and -1 plus 3. The resulting image coordinate then would be -4, +2. Our next one should be 3 and -1. We're going to subtract 5. Even though that says 2, that should be a 5. So 3 minus 5 is -2, and -1 plus 3 is +2. Our next coordinate C is at 3. We're going to subtract 5 from that x, and we're going to take that -3 and add 3 to it. That puts us at -2, 0. And finally, our last one here is 1 minus 5 and -3 plus 3. And that's going to put us at -4, 0. Now when we go to plot that, we got our A prime at -4, 2. B prime here at -2, 2. Here's A prime, here's B prime. C prime is down here at -2, 0. And D prime is at -4, 0. So if we connect all of those vertices of that quadrilateral, you'll see that this looks like a quadrilateral that was the same as its pre-image, A, B, C, D, but we moved it 5 units to the left and 3 units up. All right, example 5. We want to give the translation component form and the translation rule that moves W, X, Y, Z to its image figure W prime, X prime, Y prime, and Z prime. Now, in order to do this, we really just need to pick one vertex here. So let's pick the vertex W, and let's just see what its movement is to go from W to W prime. Looks like we're going to have to move 1, 2, 3, 4 units to the left and down 1, 2 units. So that component form would be left 4, that's -4, and down 2, that's -2. There's our translation component form. Next, let's come up with a rule. That means we're going to take each original XY coordinate and we're going to subtract 4 from the X's and subtract 2 from the Y's. Part B asks us to find the magnitude of that translation. Now, if you remember, magnitude is just the length of the hypotenuse, right? Or the length of that vector. So here's our vector that starts at W and goes to W prime. The legs of that right triangle were 4 and 2. So I'm going to say 4 squared plus 2 squared equals C squared. That's 16 plus 4. That's 20. And that's equal to C squared, but we got to take the square root of that. So C is the square root of 20, which is the magnitude of that vector. All right, in our last example for today, we got a composite translation. A composite translation is simply 2 or more translations, which is really just the result of one translation. So here's segment AB. It's got endpoints at A, which is at 3, 6. And B, which is at 5, 4. And it's going to undergo quite a few translations here. It's going to undergo 1, 2, 3 translations. We want to find the image coordinates A prime, B prime after all 3 of those translations. So remember, translations are just addition and subtraction. This component form says I'm going to add 6 to the X and 1 to the Y. Then I'm going to subtract 4 from the X, subtract 7 from the Y. And then finally this one here, I'm going to add 1 to the X and subtract 2 from the Y. So if we stack them on top of each other, we can just add down and get the one total movement that these 3 translations add up to equal. Here's what I mean by that. If I take 6 and I subtract 4, I'm at +2. I add 1 more. That's really just moving right 3 units. If I add 1 and then subtract 7, I'm really subtracting 6 now, and I subtract 2 more, then I've really subtracted 8 overall. So these 3 translations really just boil down to one general translation of 3, -8. So what is their transformation after going through a translation of 3, -8? That one rule then could be stated as all of our coordinates are going to be added 3 to the X and subtract 8 from the Y's. So this 3, 6 means A prime will now be at 3 plus 3, which is 6, and then 6 minus 8, which is -2, and B prime will be 5 plus 3, which will be 8, and 4 minus 8, which will be -4.